Let's take a look at some statistical concepts. The first we want to do is understand norm referencing versus criterion referencing in terms of testing. Norm reference tests are when scores are compared to a set of test scores called the peer or norm group. Criterion reference scores are scores that are compared to a predetermined standard or criterion. Let's think about norm reference. Imagine that we have a big group of kids who are all different ages, sizes, and ability. Now, let's say that we give them a test on the same topic. After collecting the test papers, you notice that some kids did really well, some kids did okay, and some didn't do so great. Now, instead of looking at each kid's score by itself, norm referencing means you compare each kid's score to how everyone else did. It's like saying, okay, Johnny, you got more questions right than most of the other kids, so you did really well. And Susie, you got about the same as most, so you did okay. But Bobby, you got fewer right than most, so we might need to help you a little bit more. So in simple terms, norm referencing is about figuring out how each person did on a test compared to the whole group. It helps us understand who did really well, who did okay, and who might need a little extra help. So how is this relevant to a school counselor? Well, imagine that a school counselor is working with a group of high school students who are taking a college entrance exam, like the SAT. The counselor receives the test results and notices that one student, let's call her Sarah, scored in the 90th percentile for the entire group of test takers. In norm referencing, the counselor would explain to Sarah that her score means that she did better than 90% of the students who took the test. That could be really encouraging for Sarah because it shows that she performed exceptionally well compared to her peers. The counselor might then discuss potential college options and scholarship opportunities based on her strong performance. Here's another relevance to a school counselor. On the other hand, the counselor might have worked with another student, let's call him Alex, who scored in the 30th percentile. In norm referencing, the counselor would explain to Alex that his score is below 70% of the students who took the test. This might prompt a conversation about additional support or resources to help Alex improve his skills for college application. So in both cases, the counselor is using norm referencing to help students understand their individual scores compared to the larger group of test takers. This information can guide discussions about future academic and career paths, potential areas for improvement, and support services that may be beneficial. Now let's talk about criterion reference. Imagine that you have a checklist of things to do, like tying your shoes or coloring within the lines. A criterion reference test is like that checklist. Let's say a teacher gives you a coloring book and wants to see if you can color a picture inside the lines. She gives you a list of things that you need to do, like color the sky blue and keep the red crayon inside of the apple. Each of these things is a criterion, like a rule or a goal. When you finish coloring, the teacher checks to see if you met each of these criteria. If you followed all the rules correctly, you did well on the criterion reference test. It's not about how well you did compared to other kids. It's about whether or not you met a specific criteria. So in simple terms, a criterion reference test is like following a set of rules or goals, and your success is measured by how well you measured by meeting these specific criteria. So how is that related to a school counselor? A criterion reference test for a school counselor might involve specific goals or skills related to, for example, study habits, communication skills, or managing stress. The counselor would give you a list of things to do, and if you can do them successfully, it shows that you've met the criteria for those skills. It's about focusing on your own abilities and whether you've achieved the specific goals the counselor set for you, rather than how well you compare to others. So this goes along with the Ask a National model, where we have like a pre-evaluation and a post-evaluation. As counselors, we're looking to see that the students learned the different things that were on our checklist for them to learn. So if we came into a class and we're going to work on study skills, we might ask at the very beginning, who knows about these specific study skills? If kids don't know very much, you'll do the lesson and teach them. And then at the end, you can ask the same. If the students know what they are and can explain them to them, then you know that they are doing well in your criterion reference test. All right, these are different tests that are norm referencing versus criterion referencing. Norm references are those like the GRE, the SATs, the ACT, and the MCATs. IQ tests are also norm reference, along with personality tests, career inventories, and college exam scores on a curve. Criterion reference are like the Beck Depression Inventory, college writing or entrance exam or exit exam, a driver's license exam, or the Michigan alcohol screening test, and college exams scored against a standard. So making sense of things, we have types of derived scores. Those are percentiles, standard scores, and developmental norms. Percentiles are the percentage of people falling below the obtained score and ranges from 1 to 99, with 50 being the mean. Don't confuse percentile scores with the term percent correct. So let's take a look at percentiles. Imagine that you and your friends all took a test. Now the school counselor wants to figure out how well each of you did compared to everyone else. Picture a long line where the person who did the best is on one end and the person who did the worst is on the other end. If you're right in the middle of the line, it means you did better than half of your friends and not as well as the other half. That is the 50th percentile. Now, if you're closer to the end where the person who did the best is, say the 80th percentile, it means you did better than 80% of your friends. But if you're at the 20th percentile, it means you did better than only 20% of your friends. So when a school counselor looks at percentiles, they're trying to see where you stand in the line compared to everyone else. It helps them understand if you did really well, a higher percentile, or if there might be areas where you need some extra help, a lower percentile. It's like placing you in a lineup to see how your performance stacks up against your peers. There are different types of standard scores. Ones we're going to look at are Z-scores, T-scores, deviation IQs, Stanines, national curve equivalents, college and graduate entrance exam, and publisher type scores. What is a Z-score? A Z-score is like a special tool that helps school counselors understand how well everyone is doing in school. It helps them figure out who might need a little extra help and who's doing really well, making sure that everyone gets the support they need. These are on a standard score that helps us understand where students fall on a normal curve. Z-scores help school counselors do a lot of different things. One of those is fair comparison. The Z-scores help the counselor make fair comparison between students. It's like putting everyone's test scores on the same measuring scale so they can see who did better or worse. Another thing they do is help us understand performance. If your Z-score is positive, it means you did better than most of your friends. If it's negative, it means you might need more help. The counselor can look at these scores to understand how each student performed compared to the average. Another way that it helps is identifying areas of concern. Extreme Z-scores can point out if a student's performance is unusually high or low. This helps the counselor identify areas where a student might need extra support or challenges. The Z-scores also help with intervention. If the counselor sees a lot of students with low Z-scores in a particular subject, it might mean that they need to adjust how that subject is taught to offer extra help to improve everyone's understanding. These scores also help with communication with parents and students. They provide a way for the counselor to talk to students and parents about performance in a way that's easy to understand. They could say things like, your child's Z-score is above average, which is great. Or we might want to work on this subject because the Z-score is below the average. Z-scores are calculated in this way. X is the raw score, M is the mean score, and SD is the standard deviation. Z-scores run from -4 to +4. To find a Z-score, you will do this following equation. If you want to see how Z is calculated, you can go and look on page 132 of your textbook. Here's an example that I made for Emily. Emily is in the 5th grade, and her school recently conducted a math assessment. After the scores are in, the school counselor, Ms. Johnson, decides to use Z-scores to understand how well the student performed. Calculating the Z-score, Ms. Johnson takes Emily's math score and compares it to the average score of all the 5th graders. She calculates a Z-score, and let's say that it's 1.5. And I've done that over here for you, where X equals 85, the raw score, which is what Emily got. M is 70, where most of the students are. That's the mean. And the standard deviation is going to be 10. I've used it right here to work out the calculation. So let's interpret the Z-score. Ms. Johnson explains to Emily and her parents that the Z-score of 1.5 means that Emily did better than most of her classmates. She's above average in math compared to the other fifth graders. You can also use this for positive reinforcement. Ms. Johnson uses this information to give positive feedback to Emily. She says, "Great job, Emily. Your math skills are above average. Keep up the good work." And then at a parent-teacher conference, Ms. Johnson uses Z-scores to discuss Emily's performance with her parents. She can explain that Emily is excelling in math and suggest ways to continue her academic growth. Now let's look at this example for Miguel. Ms. Johnson notices that some students have Z-scores below certain average in math topics. Miguel has a negative 2.0. This puts him over into the third percentile. This prompts her to collaborate with his teachers to develop targeted interventions for those areas, ensuring that he gets the help that he needs. Z-scores are golden, and this is why. Z-scores help us see where an individual score falls on a normal curve. They are helpful for converting raw scores to other kinds of derived scores. Z-scores can often be used to help us understand the meaning of other scores. Here we have a concept of the deviation IQ to the normal curve. Most people have an IQ around 100, but then we have those that go up past 145, and then we have those that are lower than negative 55. So sometimes people say, "Oh, I know someone that has an IQ," or "I have an IQ of 200. So this is extremely rare and controversial within the field of psychology. The standard scale for IQ test is designed so that the average score is around 100 points, and most people fall within one standard deviation of that. A score of 200 would be exceptionally high and is not typically accommodated by traditional IQ tests. IQ tests are designed to measure intelligence in the relation to the general population, and an extremely high score, such as 200, is beyond the scope of what these tests are intended to assess. In practical terms, once a person's score reaches a certain level, it becomes difficult to make meaningful distinctions between individuals. It's worth noting that IQ tests do have limitations, and they don't capture the full range of human intelligence or potential. Intelligence is a complex trait influenced by various factors, and a single number, like an IQ score, cannot fully represent an individual's capabilities, talents, or potential for success. Therefore, discussions of extremely high IQ scores, especially those approaching 200, should be approached with skepticism and may not align with the conventions of reputable intelligence testing. Here we have stanines. In simple terms, stanines are like a little group that helps the counselor understand and talk about how everyone did on a test. It's a way to make the information clear and easy to share with students, parents, and teachers. Let's say students took a test and you want to understand how well everyone did in a way that's easy to explain. Stanines are like a special way to group everyone's scores into simple categories. Here's how a school counselor might use stanines. Dividing scores into groups. Stanines divide all the test scores into 9 groups, each representing a range of scores. These scores help the counselor quickly see how everyone is doing. They also make things easy to understand. Each stanine is like a little group that makes it easy to talk about your test performance. If you're in stanine 5, it means you're doing in the middle, doing about average. If you have a stanine in 9, you did really well. This is good for quick communication. Stanines make it easier for the counselor to tell you and your parents how you did without using complicated numbers. They might say, "You're in stanine 7, which means you did better than most of your friends." This helps teachers and parents. The counselors can use stanine to quickly see which areas most students find easy or challenging. This helps them figure out where to focus efforts to help everyone learn better. Here is figure 7.5, which has stanines compared to z-scores and percentiles. Let's say we have Alex and Emily who took a science test. Alex's scores show him at a stanine of 8, a z-score about 1.5, and he's in the 92nd percentile. A stanine of 8 means that Alex's score is above average. Z-scores of plus 1.5 indicate that Alex's score is 1.5 standard deviations above the mean. The percentile of 92 means that Alex scored higher than 92% of the students. If we look at Emily's score, her stanine is about 3, giving her a z-score of about 1.0 and puts her in about the 18th percentile. So a stay 9 of 3 means that Emily's score is below average. A z-score of negative 1.0 indicates that Emily's score is 1 standard deviation below the mean. A percentile of 18% means that Emily scored higher than only 16% of her peers. In this example, stay 9s provide a quick way to understand how Alex and Emily compare to their peers in broad groups. Let's take a look at SAT scores. So SAT scores are like a report card for a special game that helps students show colleges how smart and ready for college they are. So here's how the game works. The SAT test is a test that asks questions about reading, writing, and math. Students take this test to show colleges what they know and how good they are at certain skills. So the score. After playing the SAT game, students get a score. The scores are usually between 400 and 1600. The higher the score, the better. There are 2 parts. The score comes from adding 2 parts together. One part is for writing and one part is for reading, called evidence-based writing and evidence-based reading, and the other is for math. So the average. Most students get a total score of about 1,000. If someone gets 1,000, it means they did about average. If they get more, like 1,200, they did better than average. And if they get less, like 800, they did a bit below averages. Colleges look at these scores to decide if a student would do well in their classes. A higher score often gives students a better chance of getting into the college that they want. And now we have the ACT scores. Here is the game. The ACT is a test that asks questions about English, math, reading, and science. Students take this test to show colleges what they know and how good they are at these subjects. The score. After playing the ACT game, students get a score. The scores are usually between 1 and 36. The higher the score, the better. The score comes from 4 parts: English, math, reading, and science. Each part has its own score, and then there's a total score that combines them. Most students get a total score of around 20. If someone gets a 20, it means that they did about average. If they get more, like 25, they did a bit better than average. And if less, like 15, they did a bit below average. Now we need to talk about publisher type scores. In the field of education, assessments and tests are often created and published by different companies. These assessments may generate scores using various methods, scales, or criteria, depending on the publisher's design. For example, a school counselor might receive test results from a publisher that provides scores in a unique way. These scores could be based on a standard set of standards norms or benchmarks established by that publisher. The counselor would then use these scores to understand how students are performing academically and to provide appropriate guidance or support. Now let's talk about developmental norms. Imagine that you and your friends are all growing up and going to school. Developmental norms, age comparisons, and grade equivalents are like tools that school counselors use to understand how well you're doing compared to other kids your age. Here's a simple way to look at it. Growing and learning. Think of developmental norms as a map that shows what most kids your age should be able to do or learn. It's like saying, by the time you're in this grade or at this age, you should be able to read, write, and do math a certain way. Age comparisons. When a school counselor compares your skills or progress to kids of the same age, it helps them see if you're right where you should be. For example, if you're in the 3rd grade, they'll check if you're doing things that most 3rd graders could do. Grade equivalents. Grade equivalents are like a transition tool. If you're doing math at a level expected for a 4th grader, even though you're in 3rd grade, your school counselor might say you're working at a 4th grade level in math. It helps to explain how well you're doing in terms of a different grade level. Identifying support needs. If there's a big difference between where you are and where you're expected to be, the counselor might want to help. For example, if you're struggling with reading in 3rd grade, they might provide extra support to catch you up to the level expected for your grade. So for a school counselor, developmental norms, age comparisons, and grade equivalents are like tools in their toolbox. These tools help them understand how each student is growing and learning if there are areas where a student might need some extra help or encouragement. The standard error of measurement. This is based on a reliability of a test. Let's imagine that you and your classmates are taking a big test. Now, the school counselor wants to know how reliable and accurate the test scores are. That's where the standard error of measurement comes in. Here's a simple way to think about it. Big target, small darts. Imagine that you're trying to hit the bullseye of a target with darts. If the bullseye is big, it's easier to hit, and you'll probably get close to the middle. But if the bullseye is tiny, it's harder to hit exactly in the middle every time. So test scores are a lot like darts. The test scores that you and your friends get from throwing darts at a target. The closer the scores are to each other, the more reliable the test is. If the scores are spread out, it's like the darts are hitting all over the place. The standard error of measurement, or SEM, is like a measure of how much the darts or the scores might spread out from the bullseye, the true score. If the SEM is small, it means the scores are likely to be very close to the true abilities of the student. If it's big, the scores might be all over the place. So how does this help the counselor? For a school counselor, the SEM helps them understand how much confidence they can have in the test scores. If the SEM is small, they can feel more sure that the scores are a good reflection of what you and your friends really know. If it's big, they might be cautious. So the standard error of measurement is like a tool that helps the school counselor know how precise and trustworthy the test scores are. It's about understanding how close the darts or the scores are to hitting the bullseye, the true ability of the students. Let's connect the standard error of measurement to Sarah. Sarah is taking an IQ test to measure her intelligence. The test is designed to give her an estimate of her true intellectual abilities. Sarah receives an IQ score of 130. However, no test is perfect. The SEM is like a margin of error around her score. If the SEM is, for example, 5 points, it means Sarah's true IQ score could be within 5 points above or below 130. The SEM helps us understand how precise or uncertain the IQ score is. If the SEM is small, say 5 points, it suggests that Sarah's true IQ score is very likely close to 130. If the SEM is large, let's say 15 points, her true IQ might be a bit more uncertain, and it can be anywhere from 115 to 145. Sarah's parents and teachers, knowing about the SEM, understand that the 130 IQ score is a good estimate, but there's a bit of wiggle room due for the margin of error. They might consider the range around the score to better interpret her abilities. In educational settings, the SEM can influence decisions. For instance, if a school is considering placing Sarah in an advanced program based on her IQ scores, the SEM helps them understand the level of certainty in her score and make informed decisions about educational placement. In essence, the SEM is a tool that provides a sense of how much Sarah's IQ score might fluctuate if she were to take the test multiple times. And here we have a chart on the standard error of measurement. When the standard error of measurement, the SEM, is 1 on a normal curve, it has a specific relationship to the percentages of scores falling within one standard deviation. On a normal curve, about 68% of all the scores fall within one standard deviation of the mean. So if the SEM is 1, it means that about 68% of the scores are expected to fall within 1 point above or below the mean. This is a general rule based on the normal distribution, where the majority of scores cluster around the mean, and their spread is determined or described by standard deviations. To put it simply, if you have an SEM of 1 on a normal curve, then the mean score is 100. About 68% of the scores would be between 99 and 101. If the mean score is 50, about 68% of the scores would be between 49 and 51. This is the way of expressing the expected variability or margin of error around the mean scores due to factors like random error or fluctuation in performance. If the standard area of measurement is 3 on a normal curve, it implies that you're looking at a range that encompasses approximately 99.5% of scores. Specifically, on normal distribution, About 99.5 of these scores fall within 3 standard deviations of the mean. So if the SEM is 3, it means that you're considering a broad range around the mean, which means the vast majority of the scores are expected to fall in that group. If the mean score is 100 and about 99.5% of the scores would be between 91 and 109, that would be 100 plus or minus 3 times 3. If the mean score is 50, about 99.5% of the scores would be between 41 and 59. This wider range associated with the larger SEM reflects a higher level of expected variability or margin of error around the mean score. It acknowledges that scores can vary for various reasons, and a larger SEM accounts for a broader spread of possible scores. SEM and the reliability coefficient. The reliability coefficient quantifies the consistency or repeatability of test scores. A highly reliable coefficient, closer to 1, indicates the scores are very consistent and reliable across different testing occasions. In other words, if you were to take the test multiple times, you would get similar scores. The standard error of measurement, the SEM, on the other hand, provides an estimate of the amount of error or variability in an individual's test score. A smaller SEM indicates less variability or more precise measurement, while a larger SEM suggests more variability or less precise measurement. The SEM and the reliability coefficient. Here's an example of an SEM on two test reports with different reliability. If the reliability is 0.95, that means you can see with better accuracy what the actual score is. If R is 0.70, there's a larger range where the score might fall. Standard error of estimate. All right, let's break down the concept of the standard error of estimate in a simple way. Imagine that you have a friend who's really good at predicting how many candies you can eat based on the time you spend at the candy shop. Now, your friend is good, but not perfect. Sometimes their predictions might be a little off. The standard error of estimate is like a measure of how much your friend's predictions might vary from the actual number of candies that you end up eating. It's a way of saying, okay, the prediction is usually close, but there's a bit of wiggle room. Let's say that your friend predicts you'll eat 10 candies during a visit. The standard error of estimate might be 2 candies. So it means there's a good chance you'll eat somewhere between 8 and 12 candies. The standard error of estimate gives an idea of the typical range where your actual candy consumption might fall. Let's relate the standard error of estimate to the SAT scores and first-year college GPA in a simple way. Imagine that you have a magical SAT score predictor that tries to guess how well students will do in their first year of college based on their SAT scores. This predictor is pretty good, but not perfect. The standard error of estimate here is like a measure of how much the predicted first-year college GPAs might vary from the actual GPAs, even if we know the student's SAT score. It's a way of saying, okay, the prediction is usually close, but again, there's a bit of wiggle room. Let's say the predictor estimates that if you score 1200 on the SAT, your first-year GPA will be 3.5. The standard error of estimate might be 0.3. So it means there's a good chance your actual GPA could be anywhere between 3.2 and 3.8. The standard error of estimate gives an idea of where the typical range of your real college GPA might fall. In real life, it's like saying, if you predict someone's first-year college GPA based on their SAT scores, the standard error of estimate tells you that the actual GPA might vary a bit from the prediction. It's acknowledging that other factors besides SAT scores can influence college performance. The formula to calculate the standard error of estimate for the variables in which there is a correlation is the standard deviation of the variable to which you are predicting and R, the correlation between the two variables. Now we'll move on to scales of measurement. These have uses for school counselors. Nominal scales. This is like sorting things into groups without any specific order. For the counselor, it's like putting students into groups based on things like their favorite color or their homeroom class. There's no order, just different categories. For the ordinal scale, now the counselor wants to know not just the categories, but also the order. It's like ranking students based on their favorite subjects, where the counselor knows who likes math the most, who likes English next, and so on. There's an order, but the same differences between ranks might not be the same. The last two are the interval scale and the ratio scale. This is like measuring with equal intervals. If the counselor is looking at a student test scores on a scale of 1 to 100, they know that the difference between a score of 70 and 80 is the same as the difference between an 80 and a 90, but there's no true 0 point. Getting a 0 doesn't mean the complete absence of whatever is being measured. The ratio scale. This is the most precise. Now the counselor has a scale with equal intervals and a meaningful 0 point. If they're measuring the number of books a student has read, a 0 means the absence of reading. So if one student read 10 books and another read 20, the second student read twice as many. I hope that you have enjoyed our jaunt into statistical concepts.